The edge exists wherever the digital world and the physical world intersect, and where data is securely generated, collected and processed, and to create new value. IT has oscillated over the past decade between centralized and decentralized, with edge computing, and actually has existed for many decades. There's been a time when IT was very decentralized, a time when we saw deployments of email servers in factories and remote branch offices, under desks, etc. This was not the greatest idea, but obviously that was appropriate at the time. This decentralized IT approach added cost and overheads to manage, resulting in organizations moving back to a new form of centralization, moving applications and data back into a centralized data center, private and public clouds, and everything being offered as a service. But over the past 3 or 4 years, organizations have realized that IT is not only about simplifying applications, it's more about, importantly, about transforming one's business. Real business doesn't happen in the data center or in the cloud. Real business actually happens in the factory. It happens in the warehouse, it happens in the mine, or on the shop floor, or in the cities, even in your own home. So the notion of edge computing is essentially bringing IT back to the real world, where real business is happening. Infrastructure for edge computing takes many forms as well. It can be purpose-built hardware to support hostile environments, which may be hot, humid, or dusty, etc. And these devices can range anything from ruggedized notebooks, servers, or storage. But it can also take the form of just standard notebooks, tablets, or mobile phones, or even your smartwatch. So to answer the second part of the question on why edge computing is important, it's all about the data. Data is, after all, the currency of the digital era and one of the most precious assets of any organization. It's about deriving outcomes from this data. It is expected that by 2022, that 50% of all data will be created and processed at the edge. This is a significant shift from, if one compares this to 2019, when less than 10% of data generated and processed was actually at the edge. It's the processing and analyzing of this data in real time to gain insights that is helping businesses transform digitally. The insights from the data can help organizations make faster decisions for cost saving or possibly competitive advantage. Now, the question may be asked as to why not process this data in the primary data center or cloud? Most customers have moved back to that. And the reality is that it will depend on the outcomes required. And in many cases, it's not practical or economical to possibly do that. Much of the data that is generated on the edge can and actually is analyzed and processed in centralized locations like the cloud or primary data centers. But considerations on where to process and analyze the data will depend on the laws of economics, the laws of physics, and the laws of the land or compliance. So let's consider the laws of economics issue. So network connectivity, as everyone knows, is not free. It's in many cases the sheer volumes of data that has to be inspected and analyzed that make it uneconomical to move up and down between the central sites and the remote sites. And then if we consider the laws of physics, we need to consider that in many instances, we require many immediate action on data in real time. Latency is the issue here. So data is currently unable to travel at the speed of light across vast distances. Let's consider again an example of a manufacturing facility. It's not feasible for all sensor data to be sent to the public cloud to be processed to determine if there's a possible obstruction on the production line. Outcome from this data needs to happen in real time to prevent a possible catastrophe. And finally, there are instances for security or compliance reasons that data just may not be moved. Data generated at the edge can take any form. Much of this data is machine generated, such as telemetry data from sensors, but can also include video, audio, or imaging data, etc. If we take a scenario of a mine, there are thousands of telemetry sensors continuously measuring things like temperature, vibrations, or air quality, but could also include video data from drones that could be analyzed to better manage site conditions or for security reasons. If we take another example, perhaps a retail outlet, it could be the video data measuring customers' movement in and around the store to determine the best placement of products for promotion. It could be video to detect fraud at point of sale as another example. Finally, cameras at airports or stadiums may use video data for facial recognition, for security purposes, or to validate online check-ins. The examples and types of data generated, processed, and consumed are actually endless at the edge. So data on its own is actually not important. It's about turning data into business value, preferably in real time. The value of data diminishes over time, and the quicker that organizations can act on the data, the more agile they can become. Deriving insights from data at the edge can help organizations make faster decisions. It allows them to optimize the activities at the edge, possibly to improve yields, lower costs, improve quality, or for predictive maintenance. It can enable new products and solutions to be brought quicker to market, or to improve customer experiences with personalized hospitality or inventory management. It allows organizations to gain competitive advantage or to improve safety or security. Insights are also helping to develop new edge industries with the development of smart cities, smart factories, and smart hospitals, etc. The use cases for edge computing span almost all verticals and can apply to almost all size companies in some way or form. So enabling technologies such as artificial intelligence and machine learning are leveraged in central data centers or cloud, but are also exceptionally well suited to use cases at the edge. Machines have been used for centuries to automate and simplify the physical or mechanical tasks of humans. AI takes this automation to the next level, beyond the physical tasks and into the realm of thinking and decision-making tasks. Machine learning is a branch of AI that enables systems to self-learn and ultimately get smarter or more human-like in the decision-making. The process of training the machines is iterative and requires very large data sets and often specialized computer power. It therefore makes sense for AI and ML systems to learn and develop on the job at the edge where the data is being generated. The use cases for AI and ML are almost unlimited. Some examples we see every day in our homes are your playlist on YouTube Music. The builds of the music that you like is based on your likes and dislikes. Human-to-machine interaction with Google, Alexa, or Siri, or voice and facial recognitions to access your phone. But it's used everywhere in industries as well as in the home, across all industries. So from quality control on a production line to self-driving cars. AI and machine learning are the technologies consisting of hardware and algorithms that are crucial in delivering the outcomes from the massive volumes of data being generated at the edge. Investment in IT on the edge will continue to grow massively. The IDC research company is forecasting growth of 58% on the edge between 2019 and 2023. The IDC is also predicting that by 2023, that 70% of enterprises will be running varying levels of analytics and AI workloads at the edge, and that 30% of these workloads will leverage accelerated technologies. Organizations underinvesting in technology certainly run the risk of being left behind and becoming irrelevant. So preparing and planning for the edge is therefore critically important for organizations in the new digital world. Succeeding at the edge requires the merging of information technology and operation technology systems and processes. This expansion out of the edge puts pressure on systems management and operations. And that is why we see the edge essentially become an extension of the cloud. The cloud is effectively an operating model and enables you to optimally manage your infrastructure, applications, and data in a consistent manner. So for organizations that have not already started on the path of digital transformation, then there's actually no better time than to start now. Dell Technologies, together with our partner ecosystems, are well positioned to help support and guide organizations in this transformation journey.